So thanks for coming. I'm going to be giving you a presentation on Vuforia's support for Microsoft HoloLens. But before I get into that, I'd just like to poll the audience. How many of you are familiar with Vuforia? How many of you worked with Vuforia before? Excellent. And you're Unity developers? Good. And who has seen or worked with the HoloLens yet? Okay, excellent. So before I start off, if you'd seen the keynote this morning, you saw that we have announced a strategic collaboration with Unity. What that's going to mean is tighter integration into Unity with simpler workflows and better performance for both AR and VR apps. There's going to be a lot of news coming out about that, something to look forward to. We'll talk about it over the next few months. But it's something to be very excited about, I think, for the development of both AR and VR. It's something that we're very excited about, and it's going to be great for AR developers, the democratization of AR and the future of AR technology. So having said that, let me get into my presentation. We had recently announced support for Microsoft HoloLens. It's currently in what we call an early access program, which is effectively like a beta. So you can get a version of the Vuforia SDK that supports HoloLens. You can start working with that today. And you can also get samples that'll show you how to develop a Vuforia app for HoloLens devices. In my session today, I'm going to give you a brief introduction to Vuforia, what our capabilities are, what our technology does, what the orientation of our SDK, the Vuforia engine, and the Vuforia platform is. And then I'll talk about the kinds of Vuforia experiences that are enabled with HoloLens. What do we actually do when we're working with HoloLens? How do we extend those capabilities? And then sort of an overview of the authoring workflow. When you work with Vuforia in HoloLens, it's really a visual authoring workflow, a model. It's very, very simple. So we don't have a lot of time today. I'm not going to get deeply into Unity, but I will show you the basics of the workflow. What are the steps you need to take? And what are you doing in Unity to actually create a Vuforia application? So, as you may know, Vuforia is a PTC company. Really, our focus is on solving the hard problems involved in developing for augmented reality. We focus on computer vision algorithms. We've really taken a class of algorithms, we've built them from the ground up for mobile runtimes to make them efficient computationally and to make them portable across a range of devices. That's one of the big value propositions for Vuforia, is that we offer a cross-platform solution for developing augmented reality apps across Android, iOS, and also UWP devices. And we do that in a way that involves a very easy workflow and a very logical and simple set of APIs. The Vuforia engine, which is our set of SDKs, exposes a set of features using computer vision that enable you to recognize images, three-dimensional objects, and also elements and geometry within your environment. You can recognize these things, and you can also follow them as they move in the field of view of the camera. That's really the principle of augmented reality, is that you see something, you know what you're looking at, and you're able to actually render digital content onto it so that it looks realistic in the field of view of the camera. So in a sense, the Vuforia engine acts as an eye for your camera, for your app, that enables you to recognize things and actually follow them as they move. And when it comes to, for example, reconstructing your environment, we can basically tell you what the geometry is, give you an understanding of that, and we return it to you as a three-dimensional mesh that you can use for rendering or physics, things like that. So that sounds a lot like HoloLens, right? What I'm going to talk about is how we use these capabilities to really extend the functionality of HoloLens and enable new classes of use cases, basically, that you can develop for HoloLens. A little bit of background. We've been around for about 5 years now. We had come out of an R&D group, which really, again, focused on these fundamental technologies and enabling augmented reality. We currently have over 275,000 registered developers. We have over 30,000 commercial apps in app stores. We have many apps that are under development currently as well. And those apps have experienced over 300 million app installs. This is largely a testament to the fact, as I mentioned, ease of use, democratization of AR for really all developers. You don't need to have a specialization in computer vision or any of the underlying sort of science behind this. So we make it very easy, and we enable the success of developers to create a new generation of augmented reality apps. So our offering, as I mentioned, is the Vuforia engine. This supports handheld devices like phones and tablets. We also support digital eyewear, which are devices like the HoloLens. And across that, it's HoloLens. We support ODG, Urstahout Design Group, another transparent lens, optical see-through display. Epson. We also support Google Cardboard and the Gear VR. So if you're interested in developing a range of eyewear apps for both AR and VR, we have APIs and various features that can help you with that. And our tool support is for Unity, Xcode for iOS, Android Studio for Android, obviously, and also Visual Studio for UWP. And as I mentioned again, we support Android, iOS, and Win 10 builds. So you have a range of platform tools and cross-platform build capabilities. Our own tool offerings range from an online target manager that you can use to create and manage targets. In our language, a target is really something that is predefined that you can recognize and you can use as a trackable, as we call it, meaning that you can follow it, you can recognize where it is and you can understand where it is in your environment and follow it as it moves along. We have an object scanner which is used to create three-dimensional targets. These need to have a stable geometry. It's basically a scanning workflow. You can store that and create it into a target. It's great for things like toys, action figures, things that are about tabletop size. And then we provide a tool for calibrating digital eyewear. This is very important when it comes to really enabling the precision of registered content in your environment, static registration. So when you're looking at something, that you've adjusted the calibration of the placement of the content specifically for the user's eyes. It's very important. And then we also offer a range of cloud services. So these are web-based services that support things like image recognition, also to deliver trackable images. We can hold over 1 million images in these services, and we support a REST API. So what that means is if you have an application that needs to support a large number of images or needs to version images quickly, you can basically provision those from your own content management system using our cloud services. So let's talk about our support for Microsoft HoloLens. This had come out a few months ago. We introduced support for Windows 10. Traditionally, we had been an Android and iOS platform. With our acquisition by PTC, this enabled us to branch out, support a broader range of platforms, a broader range of devices. So it's created an excellent opportunity for extending into Windows support. It's Windows 10 for the HoloLens, obviously. Also, we're supporting tablets that are UWP, and this is the Spectre and also the Microsoft Surface. Big advantage here is that, as I mentioned, we provide portability, we provide an easy workflow. What that also means is that we make it easy to develop an app for one form factor, one kind of device, and actually then migrate that into another form factor. So that means taking it from a tablet onto eyewear. The changes that are necessary really involve things like UX, but otherwise it's a very easy adaptation to take something that's handheld and move it onto eyewear using Vuforia. So it's a big advantage of working with our platform. And again, you can get all of this at developer.vuforia.com. When you go there, there's a download section. You'll see early access program. That's where you're going to get your HoloLens SDK and samples. Otherwise, UWP for Surface and such is part of the mainline SDK. So let me just give you a little bit of technical detail about HoloLens, if you haven't seen it yet, and I know there's a lot of information floating around, but just to give you kind of a high-level view of what it incorporates, what kind of features it exposes, and how you would use those. Firstly is the display. So HoloLens incorporates a waveguide display. It's the class of display that it's using. If you've seen it, the luminance is very good, the display quality is very good. This is what's enabling you basically to see the world around you, but to see digital content that's rendered in your field of view and to have it rendered accurately and to have it rendered with a high quality, high resolution. So that's really the first component. That is then backed up by depth sensing and also positioning technology. So HoloLens is incorporating, as you can see, an array of cameras. There is, when you break it down, there's active IR scanning, right? This is using a time-of-flight method. It also has an array of black and white wide field of view cameras that are offset at an angle there. This is used really for the positioning aspect. So there's two things that are taking place. One is that HoloLens is doing a spatial reconstruction, a mapping of the environment, and it's returning a mesh to you that you can use in your apps. The mesh is telling you not only the geometry of things, but really the bounds of things and the scale of things. So that's useful for a couple of purposes that I'll get into. And then the other cameras are really used to complement the depth sensing, but to understand specifically where you are in the relation of things. It's doing a positional tracking. So HoloLens is really combining spatial mapping technology with positional tracking technology. They also have, for example, gesture, which is enabled by that as well, by the depth sensing. If you've seen, there's an array of gestures. They can track really they're looking at your fingers. There's some predefined gestures. You can use those for interactions within your apps. And then there's also audio. So they have spatial audio, and they have the ability to recognize text-to-speech. So a lot of the interaction with HoloLens is driven off of gestures and off of voice. And then those are basically working with the spatial mapping and positional tracking to enable you to create applications. This is all handled by what they call the holographic processing unit. So this is really a dedicated board that they've created, right? There's a system on chip, but then there's also other application-specific systems in there that are handling things like the mesh processing, the sensor fusion, really blending the depth sensing with the other positional tracking technologies. It's handling the audio. So this is very, when you look at HoloLens, it's very finely tuned for its purpose, right? And it's this matter of giving you a high-resolution, accurate reconstruction of the environment and giving you positional tracking within the environment so that you can not only create a map, you can create a mesh of things, but you can also move around it, and it has a very good sense of where you exist within that environment. So those are at a high level, those are basically the components of HoloLens. So what is it doing? As I mentioned, it provides spatial mapping. It's creating a 3D mesh of the environment. It reconstructs what Microsoft will refer to as spatial surfaces. The map that you're getting is really, think of it like a relief. Think of it like you threw powder onto the surfaces around you and then stitched that together as a mesh. It's really giving you the contour of the surfaces. It doesn't necessarily segregate, let's say, planes from other objects or geometry in that. So you're really getting a map of all of the contours that are in front of you. And that's the spatial mapping. And what it does, which is very useful, is it brings that into a world coordinate system. So HoloLens has the notion that when you've created something in front of you, if I mapped everyone sitting in front of me and I mapped this stage, it would put me into a coordinate system, an XYZ type of coordinate system, that enabled me to understand where I was in relation to the environment. That's also used by HoloLens then to restore a reconstruction, restore the map. And what that means is that I could reconstruct the room, or I could reconstruct the space around me. I can store that, and I can leave. And when I come back, when I turn on spatial mapping again, it can use the combination of the understanding of the geometry with my position and its coordinate system to basically what's called relocalize me in relation to that. So that means you can persist something, you can leave it, you can actually share it with other people. So you could come back into the room using a HoloLens and load the same experience that I had created. So that's a very interesting capability for a range of different applications. As I've mentioned, it's putting you into a coordinate system. So it knows your X, Y, and Z. It's putting that into a world coordinate reference, meaning that that's actually a unique position within the HoloLens spatial mapping world, the scheme. And there's actually two types of references that you can use. You have yourself in the world, but you can also situate content in relation to your own position. It's called body anchoring. And what that means is that being that HoloLens has a positional tracking system, it knows where you are moving around. It can actually put content relative to you, so that as you're moving, the content's following you. Rather than being registered in the world, it's actually registered to you. So this is useful for things like, let's say you're in a game and you have a rifle or you have a shovel or something, and you want to attach things to the person or the character, so that as they're moving around, you're basically, these things are following them until they want to take them and maybe put them into the setting. It's a good way of transporting tools, transporting other things the user may be using and may need to see, and then potentially registering them back into the world coordinate system. This is also a good way of doing something like a head-up display, where as the person's moving, you would like there to be consistent display elements that are registered next to them. The other thing it's doing here is anchoring. Now, this is something we utilize. When you're moving around, HoloLens is constantly improving the resolution and precision of the map that it's creating. And one way that you can help it do that is by using what are called anchor points. So if I do a reconstruction here and I say, look, I need this to be a reliable point. When I come back, I need to know exactly where this corner is. I can make that an anchor point. And this is a way of helping HoloLens understand, look, this needs to be utilized as a consistent, persistent coordinates pose, essentially, within the environment. So that's called anchor point. We use all of these, but let me just sort of explain what Microsoft sees as really being the primary use cases for HoloLens. The first is just to put things into your environment. It's placing things, right? This is what we really help with. I'll explain this in a second. But basically what it means is that I've reconstructed the wall there, and then I would like to interactively go put something in that spot and keep it there, and then come back and maybe I'll use it again. The other thing that the map is doing for you is providing for occlusion in physics. When you have a when you have this mesh, a 3D map, you can use it to occlude using depth mapping. You can occlude anything that's behind it or is partially concealed by that geometry. And you can also use it to understand when things collide, like collision detection, or if you're using things, you want the surface to be a solid that other things would impinge on or roll off of. So you can do physics. And the other is to have navigation capabilities. So this is the matter of having, let's say, a character in the space who needs to do pathfinding, let's say, through the HoloLens world. You reconstruct your den, you have an ottoman, you have the TV, you have the sofa, you have some other stable element, and you would like there to be a character that moves around through that. You can use the mesh, and you can also even use elements of the positional tracking to do that. So what do we do, right? What is Vuforia actually, how do we improve HoloLens? And what capability do we bring in? So if you remember, I talked about the fact that HoloLens provides you a relief. It's really just giving you the contour of your surfaces. And it doesn't understand really the subject matter it's looking at. It doesn't know the contents of the scene. That's where we come in. We have the ability, again, to recognize images, 3D objects. So what this means is that if you have an image that you place, let's say a magazine, onto a tabletop in your scene or onto the floor, we can actually recognize that within the broader HoloLens spatial mapping. Within the experience that HoloLens is giving you, we have the ability to recognize discrete images and objects within your field of view, right? So that's important because you now know what you're looking at. And the other thing that we can do is actually determine specifically where that is within the HoloLens spatial mapping system. So as I mentioned, if you want to place content with HoloLens, you actually have to do it interactively. Or you have to create the map and then store it and do it offline and bring it back in. What we enable you to do is dynamically position content and also to position content with respect to something that you're looking for, something that you recognize within the scene, and to accurately do that. So we're telling you, look, here is an image. I actually have an example. Here's an image of my environment, a stones image. I've seen that, and I know it's exactly here. And what we're giving you back is a pose within the HoloLens coordinate system that tells you exactly where this is, and then we enable you to put content onto it or in relation to it, right? So it enables a new class of experiences that really aren't available with HoloLens out of the box. We're extending the capabilities of HoloLens by enabling you to recognize things and actually to know exactly where they are in your environment. So let me show you, it's a very practical use case for this. This is something that we've demonstrated before at Augmented World Expo and also through LiveWorks. What I'm going to show you is a case that's used, let's say, in a work site, where you go into the field and a worker needs to be able to basically do a diagnostic evaluation of something, and then to see a set of steps that are telling them how to fix something. So this is shown, as I mentioned at the beginning, we can support both Surface and HoloLens. So this is shown as an experience that has two modes. The first originates on a tablet, where the person's just walking up and they need to look at something. Once they realize there's something wrong, they need to put on the HoloLens so that they have a hands-free a way of interacting with this stuff. So let me show you this. Oops, hold on 1 second. Let me just get you out of here quickly and put you into the video. Excuse me. So here's the diagnostic step. Now what he's looking at, I'm going to show you this again, but there's a marker that's used to identify this specific instance of this CAT multi-track rig, and it's used to position the content. So let me just back up and I'll show you something here. You see that? This is called a view mark, right in the top there. So the view mark is a special type of marker that we've introduced. It has basically you can customize the look of it and the geometry and the contents of it. And it also has an ability to capture an encoding that you can use to store data, right? So this is one of the target types that we support. What this is doing in this environment is it enables the worker to approach this, identify the unique instance of the Caterpillar tractor, and to actually register content into that specific area of the engine compartment so that you can actually register the content onto this filter that's shown. So it enables you to understand, to recognize things, and also to precisely position content to do that. And let me just get into the workflow around that. So as I mentioned, we have unique identification. We know where things are in the environment, and we can precisely register content. That is supported by what's called Vuforia extended tracking, and I'll give you a little more information about that. Extended tracking, if you remember at the beginning I talked about our support for things like meshes, right? So extended tracking, what that's actually doing is it starts from a target, a predefined target, and then once you've recognized that, it starts picking up features of the environment and sort of opportunistically grabbing things in the environment that it can use to create a mesh of its own, right? And so it has an ability to really stabilize content by creating this kind of a spatial map around things. So that's a lot like what I described for HoloLens, if you remember. HoloLens provides spatial mapping. We provide a flavor of that through Vuforia, and basically, what that enables us to do is create a map that's compatible with the HoloLens map. And really what we're doing is passing that off to HoloLens. I'll get into the workflow around that a little bit, but I think the significant thing to understand is that with an experience where you're using Vuforia with HoloLens, the basic user experience and really the workflow itself starts with defining a target. You can see here, that's the marker I was talking about. That's a view mark. So what you do is basically define that as the starting point of the experience. When the user sees that, under the hood, you don't have to do any of this yourself. We do an analysis saying, oh, I've recognized something, I know where this is. Let me turn on extended tracking. I'd like to start bringing in other features of this environment so I can really get the best pose, as we call it. I can get the best position that we can possibly get. We do an analysis of that internally. And then automatically, we provide really the math that is transforming that position from our own coordinate system, which is relative to the camera, into the HoloLens world coordinate system. Again, this is all taking place under the hood. You don't have to do any of this yourself. We really just make it very easy to work with HoloLens for the fact that we're doing all of this hard work really for you. And again, recognition, pose, transformation, from our camera coordinate system into the HoloLens world coordinate system. Once that occurs, we basically pass it off to HoloLens. So you use Vuforia to start the experience, but then you're using HoloLens and its native APIs for the rest of the interaction. And you can return to you can toggle it effectively. You can go back and forth from HoloLens world into Vuforia and recognize new objects and environments, but really Vuforia currently is serving, again, for recognition and to basically provide a graceful transition from a known coordinate into the HoloLens world coordinate, so you can situate things, you can position things within the HoloLens world. So the workflow is really very, very simple. Vuforia in Unity is really a visual authoring workflow. As I mentioned, we support Android Studio, we support Xcode. That's a programming model. In Unity, it's really done with a lot of sort of drag and drop authoring. And that's how HoloLens is really enabled. So what you're going to do is configure your scene for augmented reality using Vuforia in Unity. You'll then add the target that you would like to use. Again, these are really added to the target manager. Everything is managed through the target manager online. And then once you have the target in the scene, you're adding any content that you want to use as a child of the target. I'll show you this in the Unity hierarchy. But it's a very simple convention in that you have a camera in the scene that you define. It's what we call the AR camera. You define a target. You ask the camera basically to look for a given target. You then have a representation of the target in the scene, which is a Unity prefab. You can see that visually in the scene, right? It actually, you can look at it. And then any content that you have. In this example, we're using the pump, right? This enterprise case that we've talked about. We make that a child of the target. And what happens really automatically in that situation is when the target is recognized, when that view mark is recognized, is it turns on all the renderers for the filter, for the content. And because it's a child, it's in the local coordinate space of the target, meaning when the target moves in the field of view of the camera, all of the content moves with that. So we're really enabling AR simply by this childing relationship in the Unity environment. It's very, very simple. And that's how we support 99% of Vuforia applications. So once you've done that, you would position any content relative to the target that you're using. You then go through the standard Unity workflow for just building, right? What platform are you going to use, Android, iOS, UWP? For HoloLens, obviously, you're building for Windows Store. And I'll show you this. And that's really it, right? So it's HoloLens, the way that we've designed this is really, the workflow is synonymous with any other AR application development that you're doing. So we don't really have time to go into Unity, but what I'd like to call out here are really the highlights of this workflow. And what you're seeing here on the left-hand side is really a standard Vuforia Unity hierarchy. If you go to developer.vuforia.com, go to the early access program, get the sample, this is what you're going to see. You'll notice here that we have, rather than a main camera, we have an AR camera, right? That's basically our scene camera for augmented reality. And you also then have the view mark that I talked about. That serves as your target. And you'll notice that the filter is a child of that, right? So the significant thing to call out here is that when we're working with HoloLens, we nominate another scene camera as the HoloLens camera right here, right? And, excuse me, hold on a second. And then what we do on the AR camera is come in, you'll see a digital eyewear behavior, and then we simply configure that to use an optical see-through type because it's transparent. And then the see-through configuration that is specific to HoloLens, and then you drag that HoloLens camera onto the central anchor point, and that basically binds the camera. What that tells the AR camera, what that tells the Vuforia camera to do, is to basically control the HoloLens camera in the scene so that when we're doing our recognition and tracking stages, that we are basically controlling the position of the HoloLens camera so that it's following our own tracking, basically. And then once we've again analyzed the pose and passed it off to HoloLens, that camera becomes independent. Now, the other significant thing is that when you're using a target in Unity that you would like to work with HoloLens, you have to turn on extended tracking. So you'll see there in blue that image at the bottom. That is a simple checkbox that you use to enable extended tracking, right? These are the two steps you need to do, is you bind the HoloLens camera to the Vuforia AR camera, and then you enable extended tracking on the target. There are a few other steps. When you go to work with this, you'll see that we have a full set of documentation as part of the sample and the EAP offering. And there are a few steps. You have to add a license key, for example, to the AR camera just to enable functionality in that environment. That's a very simple workflow. You go through the license manager. I can show you that. But really, the primary steps, again, are this camera binding and then enabling extended tracking. And then the others, just to be aware of, is that in build settings, you go in, you've probably seen this if you've worked with Unity, you enable virtual reality supported, and then you select Windows Holographic as your platform, right? So that sets everything up under the hood for Windows HoloLens. And then in published settings, there's really just two settings. You enable internet client, that's really permission. That enables you basically to call out and do a license verification with our system, so you'll want to enable that. And then the other is to enable the webcam. So one of the things we use, if you remember when I talked about the camera array, there's one other camera that Microsoft would call the PV camera, photo video. And this is a camera that sits right in between the display that can be used by third parties like ourselves. It's really intended for taking pictures, taking video. We utilize that in order to drive a lot of our functionality. So you want to enable the webcam feature. And that's really it. Camera binding, extended tracking, and then just setting up the build settings correctly. And that's it. How much time do we have? Yeah, all right. Are there any questions before they kick us out of here?
So can you please elaborate on the difference between the ViewMark and the old cloud retail target that you can associate metadata with?
Yeah, good question. So what he's referring to is that the ViewMark I'd pointed out is a new feature that we had introduced recently. Our earlier platform supported primarily image targets, and this is a good example of it. It's an image that we utilize the pattern of really contrast on to recognize and to track. So the big difference with a ViewMark and the cloud service you're talking about, cloud had supported image recognition, it supported this kind of a target, is that the ViewMark is giving you really an encodable target type. It's a marker. But basically what it's doing is it enables you to customize the look of the marker, provide unique identification of the marker type, and it also supports a range of data formats. One of the big advantages over probably using metadata is that you can support many, 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 many unique instances of a ViewMark, right? So it's much better than trying to add unique instances to how many. You couldn't, like for example, if you had this image and you needed this to be used on 1,000 different products, there would be no way of differentiating each of them individually. So in that situation, you would use a ViewMark. That make sense?
Well, if you want to have a lot of products, then you put scan by label. It's not worth as cloud retail.
Potentially. I mean, I think ViewMark it's an easier workflow. It's also going to be a more attractive option, really, for people that are deploying what they need to be a means of uniquely identifying instances in the field. The nice thing about a ViewMark is that you can control the design of it. It needs to have flat sides, but you can control really the interior design and even the geometry. And it's also a good call to action for something. So if I'm looking at a product and I see what's identifiable as a certain kind of marker, I realize, oh, okay, that's significant, and I should focus on that for whatever AR experience. Something like this is really less discernible. You know what I'm saying? You don't know what necessarily the purpose of it is.
What's the rough licensing cost structure?
So we have a range of licenses. There is a free development license that you can use really for your own development. You shouldn't deploy that. We have then an option for what we call classic license, which is really a $500 app license that you can utilize. And then we have enterprise licensing. We have specialized licensing for things like toys and product companions. You couldn't see it? So we have a range of options for dealing with that. Is using the feature extended tracking I talked about, you can actually take the content off of the target because you can use the environment. We also have introduced what we call device tracking, which you can think of as rotational tracking. So that's a way, it's a matter of, that actually uses sensors rather than the camera image, and you can utilize that really to understand the position of something relative to the user without being dependent on a target. You can work with targets with that, but it's, yeah, you can actually, all of our features you can use together. So you could start from a target, move it into another space using extended tracking, and then even transition off and use, yeah, rotational tracking, yeah.
Does it currently support all of the marker types, including 3D objects, or is it really just limited to images and viewmarks?
It can really support any of them. I mean, it's not, you have to figure with this isn't supporting, all right, I'll run through it. Image targets, view marks, object recognition, any of the predefined target types. We have others that we don't recommend it for because for example, it's useful with extended tracking. We have another feature called Smart Terrain that we're currently probably going to adapt, but we have to see what to do with that. And then there's something called a user-defined target that has the assumption that you're looking at something that's in a parallel plane to yourself. So we don't try to support that here because it's not useful for headwear. Yeah. Any other questions? We don't support barcodes. We have parties that have sort of you can obtain the camera image from us using an API, so you can actually extend what we do, and that would be the role for that. In a view mark, a lot. It's really dependent on, frankly, the size of the view mark. So it's what's useful to you. Basically what happens is as you increase the area of the view mark, you can, when you saw the edge of that, did you see the pattern of bits, effectively? So as you increase it, you can add more bits and you have a larger address space, basically. Yeah, I mean, if you wanted a gigantic one, you could potentially do something with that. Any other questions? I honestly don't have the explicit number on that. I mean, what I would recommend is try it out. You'll see that it's really to the performance that we have with any of our other SDKs.
Is the emphasis on enterprise relaxed?
I'm sorry, what was the? It's really both. I mean, the interesting thing is, which you might be commenting on, is we were purchased by a company, PTC, that does a lot of work with CAD, product lifecycle management, a lot of really discrete manufacturing, enterprise, industrial. But we have really the same focus that we had originally, which is democratizing AR really for the range of audiences. So consumer cases, also enterprise, industrial. It's really a matter of us, making it easy for this range of developers to use AR across whatever use case. So we don't really bias ourselves to that. All right, everybody. Thank you very much.